So here we go. Let's first fill out the first few things here, this theorem. So a lot of this is already filled in here. You can see what's in red, and I will scroll it in a minute, so you got to write on the notes, but let's just read the top. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional, we keep seeing the word proportional, length, aka ratios, fractions. So you are filling in the red. So if DE is parallel to AC, which is what we have over here, okay? DE, parallel, your triangles on there. Then you have those very lovely fractions, which we're going to take a look at. Let me give you a second to write. So for some reason, I think this is one of the easier sections of the four because it's so simple to set up. I don't have to read a similarity statement and match up all these letters and do all this crazy stuff. This is always going to be the situation. So look at your sides. DD over DA. So you just stay on the same side and you just write those over each other, and then you equal BE over EC. You put those sides over each other. They're always proportional. So I don't have to read a similarity statement, try to match up the letters and do all this stuff. I just have to make sure I stay on the sides. I do the left one over the right one. It's that simple, my friends. I can't believe, maybe we won't do all these examples, there's a lot of them. Now, of course, you've got the converse under it, which is really, obviously, converse from chapter 2, throwback, thinking about final exams. If, and we're going to see this on the back side of the notes, I'll show you how this works. If you have those sides proportional, so if those fractions are the same number, the same value, if I punch this fraction, the left one in, I get the same number as the right one, then the lines are parallel. So it's the reverse, the converse, which I'll show you that on the back. It's super easy. You're going to need your calculator for sure for that because we have to punch those fractions in. Make sure we get the same number. Not that that's hard, we just got to do it. All right, let's do it. Are we ready? These are so easy. I love this stuff. Okay, so take a look at your triangle. Of course, you can see the parallel sides. They tipped it over. Big deal. That's totally fine. I can start on any side I want. I'm going to start on this one because, I don't know, I feel like starting on that one. So I'm going to do the top. I'm going to do 15 first over x. And then, of course, you just match it up to the other side. Just be conscientious here. Am I going to put the other side as 14 over 12 or 12 over 14? Yeah. And I know you're very, very surprised that we're going to use cross products again. Okay, multiply your diagonals, 12 times x. 15 times 14, obviously I did that in the calculator earlier. And we're going to have a very lovely decimal answer of, this is what you're doing today, my friends. Now, it might get a little spicier on us and, we might have to distribute or something or solve for a variable with some factoring or something. But this is the deal, every single problem. That's why I love this section. Okay, yeah, it doesn't matter which one you start with. I'm going to start on the top of here. I'm going to do x over 18. So that means, what's your fraction for the other side? Is it 21 over 56 or 56 over 21? 56. There's the setup. You know the deal. I already hear you punching them in. So I'm going to have 21x. 18 times 56 is a big number. Final answer. Done. All right, let's take a look. Ooh, the next one's a little spicy trick, Ellie.
Would it matter if you put like 18 over x and then 21 over 56?
Nope, just match them up. Yep. So if you're going to do 18 over x, then flip the second one also. Okay. Yep, you got it. Now, here's really spicy part. Get ready. I say that sarcastically. So I'm going to start on this side because I don't know, I'm standing here on the left. I'm going to do x over 36. All right, my friends, you have to do a little bit of mental math. What is just this little piece going to be? The green one. 10, because of course it adds to 55, so we had to figure out 10. So now for my second fraction, I'm going to do the other side as 10 over 45. Ooh, that was a real trickster, kids, getting the 10. Ooh. Okay, x times 45, 36 times 10. What is your answer for x? Got it. So, can we handle getting that green 10? That's one of the tricks of today. Like some easy math. Okay, so here we go. Same thing. I don't know of why I always tend to start on the side with the variable. You can start on any side, obviously, you'll get the same answer, but I see the X and the 7, so that just kind of draws my eye. I kind of like to go to that one. Now again, it doesn't matter if you do a 7 over X or X over 7. We just have to keep everything lined up. I'm going to go X over 7. So that means I'm going to need this piece over 6. So a little mental math. What's this red piece here going to be? 21. So we total to 27. I'm going to let you do the cross products. You get a decimal.
24.
Got it. I feel like we're machines on this stuff. So it seems like we can handle the little spicy trick there of finding the little segment. Hey, and you know I love to review a vocabulary. We're using segment addition postulate. 2 little segments total up to the big one to find that missing piece. Can't help myself. All right, this one's pretty straightforward, nothing crazy. I don't know. I just like to start with the variable, so that's how I'm going to roll. I'm going to start with X plus 7. Of course, over at side 30. So since I set it up that way, what has to be the second fraction? So is it 25 over 15 or 15 over 25? 15, we got to start with the same corresponding piece. Now, we are going to have to distribute on this diagonal, which is not a big deal. You have your calculators. I don't have to pull up a calculator if I don't have to. I'm going to reduce 15 and 25 just to have some smaller numbers. 5 goes into there, 3, 5 goes into there, 5. So I'm going to use smaller numbers, just trying to make it a little easier on myself. Because I can, in my head, do 30 times 3. And then I'm going to do 5 and X plus 7 together, which I know a lot of you can just even skip that and go straight distributing. 5 times X, 5 times 7. You've got it from here. You're going to subtract 35, divide by 5. What is our final answer? So for this one we get minus 35, so that's going to put you at 55. 11. And you'll get the same thing if you do not reduce the 15 and 25. I just did it so I didn't have to pull my calculator and I could try to mental math it. You don't have to reduce them, but just showing you how to do that. Man, too easy. Let's do 6 and get through the back side here. Okay, let's set it up. I'm going to pick a random side. You're going to match it up. I'm going to start with 3x plus 1. So what goes underneath it? Got it. Second fraction. Watch the order. What's the second one have to be? Got it. Now again, you can roll with those 21 and the 6, but it draws my eye. Can you reduce 21 and 6?
Yes.
Yeah, 3 goes into both. And I just like to work on smaller numbers, so I don't have to pull the calculator out. 3 goes into there 7. 3 goes into there twice. So I'm going to use the 7 and the 2 just a little easier on my mental math here. So I'm going to do this first diagonal, 7 and X minus 1. I know a lot of you can just distribute it, just do it. And then I'm going to do the 2 and the 3x plus 1. And again, I know a lot of you could skip that step right there and just go to the distributive versions. Well, distributive property force 2 times 1. All right, let me give you a sec to finish that guy. I hear you already flipping the page, some of you. You got it? X is negative 9 or positive 9? Positive 9. We should have positive 9 if you subtract your 6x and add the 7. All right, so I was going to say look over the first page and see if you have any questions, but since everybody's just doing a fast flip, clearly we don't. Okay, so here's the thing we definitely need our calculators for. I'm just going to, you don't have to flip yours back, but this is, we're going to talk about this converse. We're going to test it, meaning I'm going to see if the 2 fractions equal the same number. I am going to have to pull my calculator out and do that. If they do, if the 2 sides are equal, then our lines are parallel. So we're going to test this converse here. So determine if MN is parallel. Okay, so first, of course, pick a side, doesn't matter. I'm going to start over here. So I'm going to do 11 over 15.4. Now, I don't know what 11 over 15.4 is. I'm going to punch that in my calculator in just a second. Or I should say you are. And then my other fraction, 10 over 14 or 14 over 10. Match it up. 10 over 14. Okay, your job. Punch that in your calculator for me. What's 11 divided by 15.4? Point what? Round it, right? What's 10 divided by 14?
17.
What's the decimal?
0.17.
Is this 0.71 or 0.7?
Wait, I missed
It's
it.
0.71.
0.71. I just missed it.
This one's 0.71, right?
Yeah.
Okay, I'm getting worried.
That was
That's all right. Yeah. I was like, wait a minute. So, easy question. Are the lines parallel?
Yeah.
Yes, you got the same value, so yes. So this is all we're doing is testing on the old calculator. So there's really hardly any work to show, which is great. Okay. All right, let's test this one. So I'm going to pick one of the fractions. I'm going to do, bless you, I'm going to do 15 over 4. So what's the other fraction, match it up, that you have to test? 18 over 5. Okay, punch them in your calculator. What's 15 over 4?
3.75.
What's 18 over 4?
3.6.
So, I mean, I'm really going to stop writing there because isn't it a hard, fast, easy? What's your final answer? No, they're not the same. This should be 5. I just miswrote it. Sorry, guys. Okay, questions on that. Now, do I really need a lot of work for these? No, you can just do the fractions in your calculator. All right, let's do this. Ooh, a little trick or mental math on this one. Okay, so I'm going to start over here. I'm going to start with the 30. So we're going to do 30 over 37.5. We'll punch that guy in. Now, what's your other fraction? Of course, you got the 24. What's this piece here going to be? The squiggly one. 30, I do a little mental math. 30 and 24 make the 54. Okay, punch those in. Do you get the same thing for both fractions? Yes, so yes, the lines are parallel. All right, any questions on the testing? Too easy. So all we're going to do now, we're going to get fancy on you, not really, kind of, sort of, maybe, is instead of just 2 parallel lines, we're going to have 3 parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut the transversals off, of course, keyword of this chapter, proportionally. So, of course, we're going to look at the fractions, which is what we're going to fill in over here. So first, let's fill in the if part. 3 or more lines parallel. So I'm looking at the parallel line. So my first parallel line, if AB is parallel to line CD, is parallel to line EF. Okay, that was really exciting. So I was just naming the parallel lines then. Then it says the sides are proportional, so fractions. So I'm going to put a fraction bar in. We're going to do the fractions. So again, we're going to, of course, match them up. I'm going to start on this side. I'm going to do AC first. And then, of course, CE underneath it equals, what's your second fraction going to be? What's the top? What matches up to AC? BD. That's a sloppy B, sorry. Over DF. So take a look at this, okay? Yes, it is different than the front side. The front side was 2 parallel lines on a triangle. But look at your fractions. Is the math really any different? No, it's the same. That's what I said. It's like we're doing all the same thing here, okay? Which is a nice, easy day for us. But fancy, just recognize no triangle, 3 parallel lines, okay, whatever. But the math is still the same. I'm going to start on this side. So I'm going to do 45 over 18. Okay, your other side. X over 52, 52 over X. Which way does it have to be? 52 over X. I like it. And of course, shocker news, we're going to use cross products here. So 45 times X. 18 times 52. I punched that in earlier. That's a big number. Yeah. That one I couldn't mental math. All right, what lovely decimal answer do you have?
24.8.
Love it. Any questions I can answer on that one? I don't even know if we need to do all these, but let's just pick them out, right? It's all the same stuff. Here we go. So same thing, pick a side. I'm going to do 30 over 12. What's your other fraction need to be? Got it. So you do your cross products here, of course. 12 times X. 30 times 14. I had to punch that in earlier. And our final answer for X on this guy. Got it. Obviously, this is too easy. Any questions on that one? All right, final 4. Let's do it. I missed proofs. Okay, let's set it up. I don't know why. I always like to start on the X side, just have it. I'm going to get fancy. I'm going to do 27 over X. Ooh. Okay, we're gonna do a little mental math here. What's this piece going to be if the whole thing's 30?
14.
Okay, why am I asking? You guys got it. All right, second fraction, 14 over 18 or 18 over 14? I started with 27. 18 over 14. I got fancy. Okay, of course, cross products, right? 18x. 27 times 14. I punched that in earlier. And our final answer is 21. I feel like I'm trying to keep up with you guys. All right, questions on that one? Of course not. All right, let's do the final couple here. I don't know. Do we need to do all three of these? I feel like we don't. Let's do like 13 is easy. Like this is easy. Let's maybe do. Let's do 14 and call it a day, shall we? Cross off 13. Let's just go to 14 because clearly you can see it's all the same stuff. It's repetitive, and clearly you guys got it. I can't keep up with you. I'm going to start with the 3x plus 1, and we're over 12. Okay, keep the order. What's your second fraction have to be? 18 over 24, 24 over 18. 24, good. Now, you could reduce 24 and 18. I'm going to do that. It just makes my life a little bit easier. 6 goes into both of them. 6 goes into there. 6 goes into 18. You don't have to reduce. I just like to, so I don't have to get the calculator out. All right, cross products. I can do this diagonal in my head, 4 times 12. I'm going to take 3 through 3x plus 1. A little distributing over here on the right, 3 times 3. 3 times 1. I'm going to subtract 3 over. You guys already probably have an answer and are putting your notes away. X is 5. I'm more than happy to do 15. Do you need me to do 15? Okay, that's okay.